Welcome friends. Today's topic is properties of gases and gas mixtures. Okay, the major topic. In that, we discuss about ideal gas. Okay, first we all of us know what is gas. In real world, all substance are in any one of these state, whether it is solid or liquid or gas. Okay, in the three phases only, world's all products is available. Okay, and solid means the molecules are closely packed and the molecular bond also very strong, which means it is a rigid one. And liquid is molecular bond is slightly weaker, and there's a liquid doesn't have any shape because the molecules are shared with one another. Okay, this is another phase, and third phase the gaseous phase. In gaseous phase, molecules are free. In between the bond is completely negligible. Bonding force in between the gases is completely negligible, and molecules are freely suspended in a particular volume. Okay, which means solid have a definite shape and volume, and liquid having definite volume but not a shape. It occupies its container shape. And third one, gas is a not a definite neither definite shape nor definite volume. It occupies any volume, which means it expands throughout the volume. Okay, these three phases are in the available existing one. Okay, in that one we discuss about gas. Okay, if we disturb the world, which means we change the phase from any state to another state, which means boil the water or cool the water. In a Koilpatti region, South Tamil Nadu, or India, South India, are particularly considered Koilpatti. The water is available in the liquid state. Okay, in a volcanic region, the water is available in the steam vapor state. In an Antarctic region or Himalayan, top of the Himalayan Everest hill regions, the water is available in the ice phase. If we change the water from liquid to ice in a cold pit region, it's naturally not possible. Similarly, if we change the liquid state water to steam in a coil pit region, is also not possible naturally. Okay, then we go to the artificial one, which is refrigerator. Another one is stove. With the help of stove, we convert the liquid water to steam, and with the help of refrigerator, we convert the liquid water to ice. Okay, therefore if we change the state of this system, if we want in a particular region, it's not a automatic one. Okay, if we give some input, then only that phase is changed, or otherwise we pour some amount of water from Koilpatti and go to the Antarctic region, it will form ice. And if it will if we go to the Indonesian region, a volcanic place, it will change steam. Okay, this is not possible. Okay, then these are the controversies in nature and artificial or scientific concepts. Okay, then what is ideal gas? The gas also a substance which gives certain property, certain specific heat, certain density, and certain viscosity. These are all the properties of the substance. Okay, in next semester, if you will discuss the properties in details in a fluid mechanics subject. Okay, then A gas can be modeled as an ideal gas when it has the following features. One, it has no intermolecular forces of attraction or repulsion, which means intermolecular force means consider one molecule. This is one molecule and this one molecule. This is the bonding. This is the bonding strength. This is called intermolecular force. In an ideal gas, in a real world, the intermolecular force of two substance is a negligible one, but it means the value is very small, not a zero. But in ideal gas concept, no intermolecular force of attraction or repulsion. Okay. Then second concept, the second assumption, it does not change its phase during a thermodynamic process. It does not change its phase during a thermodynamic process, which means gas always gas. Okay, it does not change liquid ice, not possible. But if we use water in a steam power plant, the first initially water is goes to the boiler and boiler heated the water and steam generated. It is a gaseous phase, and then that steam is sent to the turbine unit. Then turbine with the help of turbine, electricity generated, and then remaining steam is goes to the condenser. Here phase changing process is occurring from in that during that steam is continuously converted to the liquid. Okay, this is the vapor cycle. But in gas means doesn't change its phase. For example, bike, IC engine. If is before starting, the engine receives the air from the atmosphere. That air is reacted with the petrol and the power generated and engine run. Then the remaining waste gases is released to the atmosphere. Okay. Here consider inlet also air and outlet also air, but inlet air is fresh air, outlet air is not a fresh air. Okay, but both are in the gaseous phase. Okay, therefore we can assume that process is during that process that substance is the same phase which is gas. But in a thermal power plant is not possible. But in IC engines, inlet is gas and outlet is also gas. But those are different combinations. Inlet, the air contains oxygen, nitrogen, and those things. But exit, the emission gas contains CO2, carbon monoxide, NOx, and sulfur dioxide. Those things are available in the exhaust. But both are in the under the category of gases. Okay. Then third, it obeys Boyle's law, Charles law, and characteristics gas equation. Okay, Charles and Boyle's law we have seen one by one, and characteristic gas equation also we have seen and later. Okay, then first one is Boyle's law. What is Boyle's law? It states that when a gas undergoes a process at constant temperature, which means isothermal process. Okay, remember the first unit, isothermal process. Its specific volume is inversely proportional to absolute pressure. Okay, main parameters for any substance. Those are pressure, volume, temperature. PVT, which is the main important properties for any substance. Okay, with the help of these three properties alone, we have defined a particular system, state of the system, anything. Okay, this is enough one. Okay, here pressure and temperatures are intensive properties, and volume is the extensive property. Volume depends on mass, and pressure temperature doesn't depends on mass. Okay, then at a constant temperature, pressure is inversely or volume is inversely proportional to 1 by P. Sorry, P pressure. Okay, this is Boyle's law, very important law. At constant temperature, volume is inversely proportional or volume is proportional to 1 by P. From that, I introduce one constant, then V equal to C by P. I need to change the proportionality symbol to equal symbol. I introduce one constant which is C. Okay, say C. Then V equal to C by P. From that, PV equal to constant, where C is the constant of proportionality. Okay, then if a gas changes its state from P1 V1 to P2 V2 without any change its temperature, then P1 V1 equal to constant and P2 V2 equal to constant. From that, P1 V1 equal to P2 V2. Because during that process, temperature remains constant. Therefore, initial P1 V1 also constant and final P1 P2 V2 also constant. Then constant same. Therefore, P1 V1 equal to P2 V2, which is 1 plus 2 equal to 1 plus 2 or 1 plus 3 equal to 4, then 1 plus 3 equal to 4 and 2 plus 2 equal to 4, then 1 plus 3 equal to 2 plus 2, this concept. Okay, then these are all the isothermal process, the Boyle's law. Then Charles law. An ideal gas obeys Boyle's law. Okay, then Charles law. Charles law said that if a gas undergoes a process at constant pressure, okay, it's an isobaric process. Okay, isobaric process, constant pressure, the change in its specific volume is directly proportional to its absolute temperature. The change of specific volume is directly proportional to absolute temperature, which is V is directly proportional to T at P equal to constant. Okay, at P equal to constant. Then V is directly proportional to T. That is V by T equal to constant. V equal to Ct, then from that V by T equal to constant. So another relation. Okay. PV equal to constant, here V by T equal to constant. C is the constant of proportional to constant pressure. And for ideal gas undergoing same constant pressure, V1 T1 to V2 T2, then V1 by T1 which is equal to V2 by T2. Okay, then again another shape or another concept of Charles law is also been stated as the absolute pressure of the ideal gas varies directly with the absolute temperature if volume of the gas maintained constant. Okay, in previous case pressure remained constant, in that case volume remained constant, that pressure is directly proportional to temperature. Okay, both are in the Charles law. One case volume remains constant, another case pressure remains constant. Okay, then pressure directly proportional to T, then P by T equal to constant. From that P1 by T1 which is equal to P2 by T2. Okay, which are all the losses. Okay, first one is Boyle's law, another one is Charles law. Remember that Boyle's law is an isothermal process, boiling isothermal process, and Charles law said two different cases. One is constant pressure, another one is constant volume. At constant pressure, volume is directly proportional to temperature. At constant volume, pressure is directly proportional to temperature. Okay, these are the three relations we get. Okay, One is PV equal to constant, another one is V by T equal to constant, another one is P by T equal to constant. Then third, equation of state. The ideal gas also satisfy this equation of state. The equation of state is nothing. Observed that thermodynamic properties are interrelated. Any equations that relates the pressure, temperature and specific volume. Again I read, any equation relates the pressure, temperature and specific volume. P, V, T. Any equation relates that P, V, T, which is called equation of state, because P, V, T is a main parameters to define a particular system. Okay. For any homogeneous system, if a pressure and temperature are specified, its specific volume is automatically fixed by some functional relation. In other words, the thermodynamic properties exist in certain relationships such as function of PVT equal to 0. Okay, function of PVT is equal to 0. Main concept. Function of PVT which is equal to 0 is the main mathematical relation of a thermodynamic process. Okay, then from that, pressure is a function of V and T, and volume is a function of P and T, and temperature is a function of P and V. F, G, H is a functions. F of X, Z is a function of F, X and Y, and this thing. Similarly, I read that F is function of PVT is equal to 0. From that, pressure is a function of V and T, and volume is a function of P and T, and temperature is a function of P and V, where F, small f, G and H are some functional relationship. Okay, then characteristics gas equation. The characteristics gas equation is already we know from Boyle's law. Volume is directly proportional to 1 by P when temperature is equal to constant, and Charles' law, volume is directly proportional to T when pressure equal to constant. If you combine these two, volume is T by P, volume is directly proportional to T by P. Okay, I introduce one constant which is R, which is gas constant. This is V equal to R T by P, by to eliminate the proportionality symbol. Okay, V equal to R T by P. V equal to, which is the combination of Boyle's and Charles' law. Then from that, PV equal to RT. PV equal to RT. Pressure is absolute pressure, temperature is absolute temperature, and volume is specific volume. Okay. Then this is known as the characteristics gas equation for an ideal gas or ideal gas equation of state. Okay. That ideal gas must obey the Boyle's and Charles and characteristics gas equation. Okay. Then the molecular or molar mass, molecular weight of any substance we discussed already studied in school level. For oxygen molecule, which is 16, nitrogen 20, 32. These things are in molecular tables. In chemistry subject we discussed, we already studied in every molecular weight of a particular substance. Okay, molecular or molar mass M can be defined as the mass of 1 kilomole, also known as kg mole, of a substance in kilograms. Okay, the mass of system is a product of its molecular mass M in kg per kg mole and number of kilomoles N equal to M equal to N into M. Here, which is mass of a particular substance. Here, N into M. N is a number of moles available in the particular substance, and M is molecular weight of the particular substance, which means a substance contains a number of molecules. Consider, for example, this is the container. That container consisting of sand particles. The weight of the sand particles is M. Whole total weight of the sand available in the beaker or container is equal to M, which is nothing but number of sand particles and weight of the each sand particle. Understand the concept? Overall mass of the container, sand available in the container, which is equal to number of sand particles into molecular weight or mass of individual mass of the sand molecules. Okay, same concept. If a container contains any gases, the gas means when gases having molecules, then overall mass of the gas available in the particular region, which is equal to number of moles, which is nothing but number of molecules available in the particular volume into molecular weight of the individual molecules. Okay, please understand. For moles means numbers, and M means this capital M symbol means molecular weight, and small m means total weight of the total mass of the particular substance. Okay, then N is moles and M is kilogram per kg mole, then mole cancel, then we get kilograms. Okay, then from that volume equal to total volume equal to mass into specific volume. Okay, specific volume means anything divided by any extensive specific properties means extensive property divided by unit mass, which is called specific properties. Total enthalpy capital H is equal to M into H, small h, which means specific means kilogram per kg. Okay, from that total volume is equal to mass into specific volume of a particular container. From that PV, total volume, PV equal to MRT. In previous equation, small v, specific volume. In that equation, I substitute total volume. Okay, is M into V, then we get PV equal to MRT. Another equation. Okay, then molar basis means I already said number basis. Okay, another one is we have two analyses. One is mass based analysis, another one is volume based analysis. Volume based means number of molecules based analysis, and mass means total mass based analysis. Okay, for a particular application we have discussed, because in gases having doesn't the shape and doesn't have any volume, but a fixed gas having a fixed region, in that fixed region the number of molecules are fixed. Okay, number of molecules are fixed, but volume doesn't fixed, and we cannot measure the mass of the gases very easily. Okay, therefore the volume is equal to N into V. The V bar is a molar specific volume. Okay, same concept. Total volume, which is equal to number of molecules available in the that particular region and individual occupied volume of molecules. Therefore, V equal to M into V. Okay, then from that PV equal to NRUT. PV equal to NRUT. RU is the universal gas constant. It's based on the molecules, type of molecules. What type of molecules? Okay, RU is a universal gas constant. It doesn't depend on the type of molecules. But in previous case, R, gas constant, specific constant, is based on the what type of molecules, either whether it is oxygen, whether it is carbon dioxide, those individual having different R. But in that case, Ru is a universal gas constant, which is doesn't change with molecules. Okay, then PV equal to Ru by Ru into T. Here Ru equal to M into R. M is molecular weight of the substance and R is gas constant. Okay. Universal gas constant M into R. Universal gas constant means when the molecular mass of any gas is multiplied by its specific gas constant, it is observed that product of M into R is always same for all gases. This product is called universal gas constant and it is denoted as Ru. Okay, that value is 8.31447 kilojoules per kg mole Kelvin. The next, characteristics gas constant. Okay, the constant of proportionality used in previous equation is called specific gas constant. Okay, its value is different for different gases. Okay, that characteristic gas constant and is multiplied with the molecular weight of the particular substance, which implies same value for all gases in the available in the value. This is called universal gas constant, and this is suffixed by Ru, and another is R. Okay, then change of state of an ideal gas. Change of state of an ideal gas. Change of state means position change from one situation to another situation. For example, 0 degree Celsius to 100 degree Celsius, or 25 degree Celsius to 25 degree Celsius to 0 degree Celsius. This is the change of state. Okay, for ideal gas, state 1, P1 V1 divided by T1 into Mr, and P2 V2 divided by T2, because PV equal to MRT. M is constant and R also constant. Therefore, variables are PVT. Then initial state 1, P1 V1 by divided by T1, and state 2, P2 V2 divided by T2 equal to constant. From that, MR is equal to same. Therefore, P1 V1 divided by T1, which is equal to P2 V2 divided by T2, which is equal to constant. Okay, this is the property relations of the ideal gas. Okay, and last topic is Avogadro's law. It's also studied in a school level. Avogadro's law or Avogadro's hypothesis. Okay, it states that the molecular mass of all perfect gases occupies the same volume under identical conditions of pressure and temperature. Avogadro's experiment shows that the average volume for 1 kilomole for any perfect gas is 22.413 meter cube at standard atmospheric pressure and 0 degree Celsius. Okay, again I tell, it states that the molecular mass of all perfect gases occupies the same volume under identical conditions of pressure and temperature. Okay. The molecular mass of the all perfect gases occupies the same volume under identical conditions. Okay, this is the concept. And then the Avogadro's experiment shows that the average volume for 1 kilomole for any perfect gas is 22.413 meter cube at standard atmospheric pressure 1.01325 bar. Okay, from that V equal to MRT divided by P. Okay, MR is nothing but RU T divided by P. And RU divided by RUT divided by P. RU is 8.31447 and temperature 0 degree Celsius is nothing but 273 Kelvin, and pressure is 1 bar equal to 101 kilopascal, and substitute that V equal to 22.413 meter cube per kg mole.
1 kg mole,
which means 22.413 meter. Okay, the unit conversion. The 1 kg mole is equal to 22.413 meter. Okay, this is the law of Avogadro's. Okay, these things are today discussed. One is ideal gas concept and assumptions of ideal gas, and three laws: Charles and Boyle's law, and characteristic gas equations, and characteristic gas constant, and the equation of state, and last one is Avogadro's law. Okay, thank you.